Welcome to my channel STEM Cafe. Here I make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. Today in mathematics, we are handling summation of series. We all know what series are. A series is sum of the terms of a sequence. Sum of the terms of a sequence. We all know what sequences are. Sequence can be described as arrangement of numbers under specified rules. Like if I have arrangements like this: 1, 3, 5, 7, like that. You know, I can define this as, describe this as 2n minus 1. Under these rules, this one will obey. This is the first term. 2 times 1 minus 1, 1. 2 times 2 minus 1, 3, and it goes like that. Now, if I want to sum this and express it as series, this is the sequence. This is the series. It's going to be 1 plus 3 plus 5 plus 7 plus. That's the series. Let's just put this one as 2n minus 1. So n term plus 2n minus 1. N terms. So, summation will be the answer to this. When you sum it up to this place, that is the summation. Now we have worked this out under geometric progression, under arithmetic progression. And it is this knowledge you will use to find the summation of series that involves r squared, r cubed, r raised to power 4. Before we further, we need to understand what this sigma notation is about. This sigma notation is about summation, and it is used to define the summation within certain range. If I have something like this, from r equals to 1 for 2n minus 1, it means that I will start using this from 1, this formula, to define the sequence from 1 to n, and I will add everything. So this sigma notation is for summation. And it makes our work easy because it shortens the write-ups. It reduces what we are going to put down. So it is very good you understand this sigma notation, though not too much in this level. Now, since we have been able to do this, let us start. And we start with the summation r, when the power is 1. Now let's look at AP. In AP, arithmetic progression, we have A as the first term, D as common difference, and N as nth term, number of terms. So, if we want to find the sum of AP, we are going to have, that is for sum, we are going to have something like this: n over 2 into 2a plus n minus 1 into d. Now, for our natural number, we are going to, our number a is 1. That is the number, the first number. D, the common difference will be equal to 1. You can see. So, in this place, we can say, if we want to use our sigma notation, we can say it's equal to r, because we use r to depict our natural number. You can see, from r equals to 1 to n, and it's going to be equal to n over 2. What is our a? 1. N minus 1 into 1. And that is going to be n over 2 into 2 plus n minus 1. That gives me n over 2 into n plus 1. You can see. So, if I have to express this, I can say it's n squared plus n over 2. So this is the summation for natural numbers. Summation for natural numbers. Another way you can also use, arrange it forward, arrange it backward. Okay, let me quickly do that. Now, if you look at it like this, just like the way we got this formula, where we said, in this instance, Tn, n star, is equal to a plus n minus 1 into d. We will now arrange it forward, arrange it backward, and then we sum the whole thing. Like this, Sn will be equal to a plus d plus a plus 2d plus a plus 3d. So a plus n minus 1 into d. Sn is also equal to a plus n minus 1 into d plus a plus n minus 2 into d. So this one will go with this one will go with this, and until we come to this place, we are going to have a. By the time you add it, this is just the derivation, how this formula was gotten in the first place. You are going to have 2a plus n minus 1 into d. By the time you add it up to this place, it's going to be multiplied by n. So you can see. So at the end of the day, Sn is going to be n over 2 into 2a plus n minus 1 into d. So you can see, very simple, very straightforward. Since you can understand how this is derived, this is how this answer is even derived in the first place. Why don't we arrange the natural numbers forward and the natural numbers backward? And from there, we'll see what our answer is going to be. Now, so summation r from r equals to 1 to n is going to be 1 plus 2 plus 3 plus 4 plus 5 plus n. In the same way, I can say n plus n minus 1 plus n minus 2 plus n minus 3 to n to 1. So by the time I add everything, this one is going to be 2 into summation r n plus 1. This one too is n plus 1. By the time you do that to this thing, it's going to be multiplied by n. So you can now see that n into n plus 1 over 2. Now since you have gotten it like this, let us see. By the time we expand, it's going to be n squared plus n over 2. So you can see that when we added r with power of 1, we were able to get n squared in our answer. Let us now see if we can work this backward and come back and see if we can get the same answer for the summation of r. Now to enjoy this better, it's good you understand a little bit of binomial expansion. Or if you have not really studied binomial expansion, you can easily know that when we have n plus 1 raised to power 2, it's going to be n plus 1 into n plus 1. Just multiply it out, you get your answer. So if you have n plus 1 raised to power 4, it's going to be n plus 1 into n plus 1 n plus 1 into n plus 1. Or if you have, can be n plus 1 squared into n plus 1 squared. So depending on how you want to do it, I'm just trying to see how it can be easy for you to work it out. So, but if you have known this, it's very easy and you get it fast. Now we are still on the natural numbers. When we have r, let's say we have something like this, n plus 1 squared. You know it's going to be n squared plus 2n plus 1. This is a term, r. Another one is going to be r. This is n. It's going to be n minus 1 squared plus 2 into n minus 1 plus 1. N minus 1 squared, please. It's going to be n minus 2 squared plus 2 into n minus 2 plus 1. Now, if I continue, let me get to something like 3 squared. You know that will be 3 minus 1 squared, that is 2, plus 2 into 3 minus 1 plus 1. So let me see. 2 will be equal to 2 minus 1 squared, that is 1 squared, plus 2 into 2 minus 1 plus 1. Here, 1 squared here is equal to 1. Now, by the time you look at this one is going to be summation r squared from r equals to 1 to n plus 1. You can see 1, 2, 3 to n plus 1. And that's going to be, if you look at this, from here, we have 1. Please take note, this one is going to be, so we are starting from here, 1 to n squared. So summation r equals to 1 to n r squared. And this one too, plus 2, summation r from r equals to 1 to n. See. And this one, by the time you check it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, everything to n plus 1 plus n plus 1. Because by the time you count this 1, 1, 1, everything, by the time you multiply it, is going to be this equal to this, n plus 1. So please don't be confused. This is the sum for this place. This one is the sum for this place. This one is the sum for this place. And this one is for the sum. You can see that there is extra 1 after this place. Please take note. Now, if we subtract this one from this one, that is summation r squared n plus 1 from r equals to 1 minus summation r squared n plus to n. You know, this one is equal to n plus 1 all squared plus summation. I want to take note of this. This one is this. So at the end of the day, this one is equal to n plus 1 squared. When I subtract this one, it's going to give me n plus 1 squared. So from that place, we can work this further. So let me simplify it then. So this one is going to be n plus 1 squared plus summation r squared from r equals to 1 to n is equal to n r squared plus 2 n r equals to 1 r plus n plus 1. So you can see it has made it very easy now. So from here, if I subtract this from both sides, I'm going to have n plus 1 squared is equal to 2 plus n plus 1. So on subtracting n plus 1 from both sides, I'm going to have 2 is equal to n plus 1 squared minus n plus 1. So it's going to be n plus 1 into n plus 1 minus 1. This is n into n plus 1. So it means that it's equal to n into n plus 1 over 2. So you can see, it is consistent with the answer we got initially. Everything is the same. So, which means that if you want to find the sum for the squares of natural number, you can go in this way. The sum for the cube, for the raised to power 4, let me make it easy for myself, is you can do it in this way. So let's see what we can do now. Now, let's see. For summation r squared, let's start with n plus 1 cube. This is going to give us n cubed plus 3n squared plus 3n plus 1. So let's start with n plus 1 cubed, and that's going to give us this. Now let's do the working. So we have n plus 1 cubed to be equal to n cubed plus 3n squared plus 3n plus 1. N cubed will be equal to n minus 1 cubed plus 3 into n minus 1 squared plus 3 into n minus 1 plus 1. N minus 1 cubed n minus 2 cubed plus 3 into n minus 2 squared plus 3 into n minus 2 plus 1. So if I should just come like that, I get to something like this, 3 cubed. It's going to be 2 cubed plus 3 into 2 squared plus 3 into 2 plus 1. 2 cube will be equal to 1 cube plus 3 into 1 squared plus 3 into 1 plus 1. Now let's make it 1 will be equal to, when you do it, it's going to give you 1 here again. So by the time I sum this, I'm going to have summation. Okay, to make it easy, I just say n plus 1 cube plus summation n cube from 1 to n. So it's going to be n plus 1 cube plus I think it makes sense. From this place to this place is equal to this. And then this one is up. Will be equal to that's it, from here to here. Plus 3 into summation r squared from r equals to 1 to n. That's it. From this to this. Plus 3 into summation r from r equals to 1 to n. From here to here. So from here to here. Please, this one is not part of it. I just use this one as explanation. That one is not part of it. So for this place to this place, you can see that place is equal to n plus 1 as before. This place is n plus 1. Now, by the time I continue, this one and this one will cancel. So this one will be equal to this place. Let's continue. So now, this one is going to be n plus 1 cube. This one and this one will cancel out. So I'm going to have is equal to 3 summation r squared from r equals to 1 to n plus 3 summation r equals to 1 to n plus n plus 1. This one, you can see, I can bring this one out and say n plus 1 cube minus n plus 1 is equal to 3 summation r squared from r equals to 1 to n plus 3. You know the expression for summation r from 1 to n is equal to n into n plus 1 over 2. Remember. So let me bring everything from this place to this place. So I'm going to have, let me factorize this. This one is going to be n plus 1 into n plus 1 squared minus 1 minus 3 into n plus 1 over 2 is equal to 3 summation r squared from r equals to 1 to n. Bringing this one here again, I can still factorize this one further. So it's going to be n plus 1 into n plus 1 all squared minus 1 minus 3n over 2 is equal to 3. Expand. When I expand this to give it, let's see. So it's going to be n plus 1 into, this one is going to be n squared plus 2n plus 1 minus 1 minus 3n over 2 is equal to 3 summation r squared r equals to 1. So you can see this is where the work is now. So let's concentrate on this. So this is going to be n plus 1 into n squared 2n minus 3 over 2n, that is n over 2 plus n over 2. This one you cancel. 1 minus 1. So look at it again. N squared is 2n minus 3n over 2n, n over 2. 1 minus 1, 1. So I'm going to have, let me divide this by 3. So it's 3. So I'm going to have n r squared. So the job is easy now. The job is easy now. So to make it, I can now say n plus 1 into 2 n squared plus n over 2. This one is over 3. Is equal to. So you can see, I can still factorize this further. I can still factorize this one further. So note this answer here. Please follow the steps. Very easy. So this now can now be n plus 1 over 6 into n into 2n plus 1. You can see it's going to be equal to n into n plus 1 into 2n plus 1 over 6. That's the expression for the sum of r squared from r equals to 1 to n. Now let's put the answer to test. Let's find the summation of so that's going to be 1 plus 4 plus 9 plus 16 plus 25. This is 55. Now, let me put 5 into this formula. That is 5 times 6 times 11 over 6. So you can see, our answer is correct. So for the first one is n into n plus 1 over 2. For this one is n into n plus 1 to 2n plus 1 over 6. Now let's see if we can work on q. Now, let us work out the summation of q. And what are we going to use? We are going to use n plus 1 raised to the power 4. On expanding this, we are going to have n raised to the power 4 plus 4n cubed plus 6n squared plus 4n plus 1. That is what the expansion of n raised to the power n plus 1 raised to the power 4 is. Now let's do it as we did the previous one. This one is going to be n plus 1 raised to the power 4 equal to n raised to the power 4 plus 4n cubed plus 6n squared plus 4n plus 1. Here, n raised to the power 4 is going to be n minus 1 raised to the power 4 plus 4 into n minus 1 cubed plus 6 into n minus 1 squared plus 4 into n minus 1 plus 1. N minus 1 raised to the power 4 is going to be n minus 2 raised to the power 4 plus 4 into n minus 2 cubed plus 6 into n minus 2 squared plus 4 into n minus 2 plus 1. So if I should come down, I should continue like that, and then we come to 3. Raised to the power 4 will be equal to 2 raised to the power 4 plus 4 into 2 raised to the power 3 plus 6 into 2 raised to the power 2 plus 4 into 2 plus 1. 2 raised to the power 4 will be equal to 1 raised to the power 4 plus 4 into 1 raised to the power 3 plus 6 into 1 raised to the power 2 plus 4 into 1 plus 1. So 1 raised to the power 4 will be equal to 1. Let me dash here. Now, just like we did in the previous one, I like to express this as n plus 1 raised to the power 4 plus summation r raised to the power 4 from r equals to 1 to n. You know this one got to n plus 1. So I added it from here. This is the expression from here to here. So this one is this. So now you can see that this same expression is what I have here. And that's going to be n for r raised to the power 4 plus, for this one, from this place to this place, you can see is summation r cubed from r equals to 1 to n. So I have 4 here. 4 here. So here too, plus 6 r squared from r equals to 1 to n plus 4 summation r from r equals to 1 If you count from this is 1, this is n, plus this one is n plus 1. I have n plus 1. So, please note this. From this place to this place is equal to from this place to this place. From this place to this place. So, I can easily delete this. Then this one will be equal to this here. Guess what it is? So, from this, I can now say n plus 1 raised to the power 4 is equal to, this one we cancel. 4 summation r cubed from r equals to 1 to n plus 6 summation r squared from r equals to 1 plus 4 summation r plus n plus 1. We know the expression for this. We know the expression for this, and then we can easily work this out. Now, we have n plus 1 to the power 4 equals to 4 summation r cubed from r equals to 1 to n, 6 summation r squared from r equals to 1 to n, 4 summation r from r equals to 1 to n, and n plus 1. We can think further by saying 4 summation r cubed r equals to 1 n plus 6 into n plus 1 2n plus 1 over 6. Here, plus 4 into n plus 1 over 2 plus n plus 1. You can see. So, we have this out. We can still factorize this. Okay, this one, we have 2 here. So, we are going to have 4 summation r cubed from r equals to 1 to n plus we go to 1 to n. So this is going to be n plus 1, and here I have 2n squared plus n. This one is plus 2n plus 1. You see? Plus 2n plus 1. So 4 summation r cubed from r equals to 1 to n plus n plus 1. If you look at this, 2n plus 1 is a common this thing. So here, so you can see, this one is 2n squared plus 2n plus n plus 1. So let's continue. Into n plus 1 plus n plus 1. 4 plus n plus 1 n plus 1 into 2n plus 1. And that gives me 4 summation r cubed from r equals to 1 to n plus n plus 1 all squared into 2n plus 1. So here, n plus 1 raised to the power 4 is 4 summation r cubed into n plus 1 raised to the power 2 to 2n plus 1. So let's see what it gives. Now, 4 summation r cubed from r equals to 1 to n will be equal to n plus 1 raised to the power 4 minus n plus 1 squared into 2n plus 1. So this is going to give me n plus 1 squared into n plus 1 squared minus 2n minus 1. So this is n plus 1 all squared into n squared plus 2n plus 1 minus 2n minus 1. And that gives me n plus 1 all squared into this one and this one into n squared. So summation r cubed from r equals to 1 to n is equal to n plus 1 into n squared over 4, which is n into n plus 1 over 2 or squared. Can't you see that this one looks like the sum for natural numbers all squared? So you can see, just follow the process, you get your answers. So we got for n summation, we got for summation r squared, and for summation r cubed. If you follow this process again, you can get for summation r raised to power 4. So we have to pause at this stage. So kindly share, subscribe, comment, like. Let others who have not known about it know about it. And please, it's beneficial if you subscribe so that any video that is posted from our channel, you'll be among the first to see this. Thank you very much. And anything you need, anything that you believe we need to do to promote this channel, to improve this channel, please kindly get to us through the channel in the description or the comment section. Thank you so much. If you have any questions, please direct it through this channel as well. I appreciate you. Thank you very much. God bless you. See you in the next video.